Good morning, good afternoon, and good evening from depending on wherever you've joined from. My name is Rohit, and I will be your host for today. Welcome to another webinar by Data Platform Geeks. Today's session will be on SQL Server 2017, Adaptive Query Processing and Automatic Tuning, and it will be taken by Javier Villegas, who is an MVP from Argentina. And I have Satya Ramesh with me, who will be moderating today's webinar. Most of you must be knowing Data Platform Geeks is a community initiative by eDomino Systems. We do a lot of free events under Data Platform Geeks. We also have the annual feature, which is Data Platform Geeks Annual Summit, Data Platform Summit Annuals. We recently concluded Data Platform Summit 2018, which was a huge success. I will talk about it in some time. We also have SQLMaestros, where we offer trainings through masterclasses and HOLs. We do have Peopleware India, which covers a lot of other technologies, and also expand SMERP. As I earlier said, Data Platform Summit 2018 concluded in August. It was a 3-day conference from 9th to 11th and pre-cons on 7th and 8th. As you can see in this picture, it was a huge success. We had more than 900 delegates participating in the summit from over 15 countries. We had more than 60 speakers taking more than 100 sessions. This picture was taken immediately after Rohan Kumar's keynote, who is a corporate vice president for Azure Data Group. We've already started working towards Data Platform Summit 2019. This time we will be having 3 days of pre-con and 3 days of summit, and 7 tracks and 100 plus sessions again, and with 50 plus speakers. This is the DPG core team: Amit Bansal, the founder and president, and Manohar Punna, who is the vice president. We also have a lot of regional mentors, and these are the eDomino teams from Kolkata and Bangalore who worked behind Data Platform Summit. This is at the summit this year, where you can see the DPG core team and the eDomino teams. Special thanks to Microsoft for supporting us in our community initiatives. You all must be already part of Data Platform Geeks if you are here. You can all use all the free content that we have out there. We have free technical webinars as well as in-person events which you can explore. If you have any questions, you can always join our Facebook and LinkedIn groups, post your questions and answer questions of other people. Here we have new links where YouTube, we upload our webinars, and also we have a mobile app called Telegram where you can join the community. With no further delay, I will hand it over to the speaker to start this session. And all of you, please post your questions in the Q&A panel. And at the end of the session, the speaker will answer all your questions. Over to you, Javier.
Thank you. Can you hear me?
Yes.
Oh, okay, good, perfect. Good morning, good afternoon, good evening, everyone. Let me share my screen. Here we go. Hello again. My name is Javier Villegas from Buenos Aires, Argentina. And today we're going to be talking about some exciting features in SQL Server 2017, adaptive query processing and automatic query tuning. Okay. Not. Wait a second, the presentation got stuck. 1 second, it's a good start. One moment, please. you still see my screen, right?
Yes, Javier, we can see your screen now. So you just need to open the deck.
No, it's just my PowerPoint just crashed on it. Sorry about that.
Okay, no issues. We'll just restart it, no issues.
Here we go.
Yes.
A little bit about me. I'm a DBA manager at Mediterranean Shipping Company. I'm working with SQL Server since the very first versions. I am specializing in SQL administration, performance tuning, and high availability. I am Data Platform MVP and forum contributor. I'm also technical speakers in different online and in-person events such as NetConf, 24 Hours of Pass, SQL Saturdays, Group Buy, and since a few months back, DataPlatformGeeks as well. And I'm a member of the PASS group, SQL Argentina, down here. You have my Twitter handle and my LinkedIn, so feel free to contact me. At the end of the presentation, I will also post my contact information so you can reach me for any topic related to this presentation or anything you want to talk. I always say that I like to be in touch with the community, so feel free to ping me at any time. All right, this is the agenda of the things that we will be covering today. We're gonna do a quick review of Query Store. Then we will go to the most important features in 2017, like automatic query tuning and adaptive query processing. Well, Query Store was born with SQL Server 2016 and was the first approach that Microsoft provided us to generate better, or let's say more stable execution plans, right? How is that? Basically, with Query Store, we are able to enable this feature and, like, you know, a black box on a plane, being able to capture all the workload information that we have on a particular database, such as all the execution plans, as well as statistical information like reads, writes, CPU usage, execution count, etc., etc., etc. Right? So for every single activity that we do on a particular user database, is get recorded, right? Then we will see how we can use all that information, right? In SQL Server 2017, Microsoft added the possibility of also store information related to the wait stats, right? For every single query or store procedure. So this way we can also track what each query is waiting for, right? So that also was a huge addition. Well, we know as DBA that the execution plan changes over time, right? And because of different reasons. For example, changes on statistics, deletions or recreation of schemas, indexes, right? So, you know, SQL Server will generate a plan, and you know, sometimes it's not the best, right? And when it changes, you know, we can be affected for this. I mean, by this problem like query regression, right? So that's the case in where we have a report that every day takes, you know, 5-10 minutes to run, and then one day in the morning we arrive to the office and the report is been running for 4 hours and with no changes, right? So that is how Query Store is going to help us. storing all the different changes and the stats execution, right? Okay, procedure always store the latest execution plan, which is the one that is in use, right? So with query store, we are able to identify query per query every single execution plan. And if we want to, we can force a particular query to use a particular query param, right? So we're gonna see from Management Studio that we will have the ability of seeing all these plans and, you know, upon our decision, decide to force to use that one in particular, right? So that's good, because with that, we're gonna solve that problem that I mentioned before, right? If we have that critical report that runs every night, we can force to always use the same execution plan, and with that, we're gonna be kind of covered, right? I would like you to emphasize on a particular sentence, right? With query store, we are able to force the execution plan manually, query per query, right? So we are the ones who has to identify the regression and manually specify the querying plan to be used, right? Okay, this is an overall picture of how query store works, right? SQL Server compiles our query, right? And when it compile it, right, then it execute the query, right? So within query store, the plan that got compiled gets stored, right? And after the query is executed, right, it also stores the runtime statistic, such as reads, writes, CPU counts, etc. Right? And in an asynchronous way, it's just get all the data and save it within the query store schema on the same user database. Right? It's quite simple to enable it. Something to focus on also is that if you want to use query store, you have to use it. You have to enable it per database, right? Database per database. Right? This is how it works. Okay, this the much you could enable query store. It's so simple, right? We have an on-off switch, so we can easily enable it, right? Then there are some other settings that we gonna be with later. But to discussing where we can use and take advantage of query store. First of all, for quickly found and fix performance related problems, right? Related to plan regressions, right? So that's the main purpose of query, right? Since we are also storing execution statistics, right? We can determine the amount of time that a particular query or report has been executed in a time frame, right? That's gonna help us, the DBA, to take better decisions on to use certain resources. So this particular query store procedure has been executed 10 times in the last, minute and a half or whatever, right? And we can keep track of stats, right? Also, we can identify the heaviest query, all the heavy workload, right? And this way, we can, take this heavy queries, analyze the query plan, and try to rewrite it to make them better, right? So this is all something that we're gonna see it from the query store panel, right? It's quite simple. And now in SQL Server 2017, with the addition of weight stats, right, we can also see for which this is from our store with a bunch of predefined reports, right? This way we can easily and graphically identify, for example, all the queries with regressions, all the queries that are consuming resource, the top resource consuming queries, right? We can also see the queries that are running with the force execution plan that we set it up, etc. Right? And then, you know, with query store, all this data is stored within the database, and then with T-SQL, we can also get our own reports. On the right side, we have the examples of how to enable query store using T-SQL. Right? Alter database, set query store on. Right? Then the second statement is SP query store force plan. Right? This is the way from T-SQL on how we can identify a particular query, a particular plan ID, and force it. And then the last example is how to revert that, right? How to enforce a fixed plan, right? Here are some tips on best practices using query store on heavily loaded environment, right? If you have a production environment that runs very low, here are some tips. I encourage you to go to or take note on the link that is on this slide, because you know there are certain important settings that are really good to be used on this kind of environment. Like, for example, some trace flags that will change a little bit the behavior of query store, right? But just to, you know, consider, we have to, you know, verify continuously ourselves that query store is working. There are several capture modes, right? Like, for example, capture everything or just discard those ad hoc queries that are, you know, insignificant, right? So let's try to keep the most relevant data in query store. And well, if possible, I know that sometimes it's complicated, avoid the drop and create pattern, right, on databases that we have query store enabled, and so on, right? But you know, it's important to pay attention of the best practices on mission critical servers, right? All right, let's switch to the next feature, which is automatic query tuning, right? As we said before, with query store, we can store the information of execution and workload and statistics, right? So we just store it, and then, as I said before, and as I put quite emphasis, right, we can manually set or force a particular plan for a particular query, right? So let's go back to the initial example that I made, right? We have this report that it's taking 10 minutes, right? It runs at 3 a.m. in the morning. And then when we arrive at 8 a.m., right, it's still running, right? So we start receiving phone calls, right? So between 3 a.m. and 8 a.m., that particular report was running with a non-good execution plan, right? So how can we take advantage of automatic query tuning? Okay, enabling automatic query tuning will allow us, or actually the SQL engine, to automatically, right, decide or check for every single query or store procedure that is executing, right? If there is a regression with the execution plan, it will automatically force the last known good execution plan, right? So,
Xavier, sorry to
yes,
interrupt you. So there
yes.
is some buzz noise is coming up constantly. So not sure why some buzz noise is coming out constantly. Beep, beep like that.
I heard it, but I'm also hearing it now. Isn't it? It's not coming from your end because I
Yes,
heard it.
it's still
Now I
coming up.
hear it.
Yes, it's still coming up. Yes. So
Let me see if
which
I can
side?
switch. If I can switch the headset. This is
Yes, yes.
1 second.
Yes, seems like the issues with the headset. Now it's constantly beeping.
Hello, is it better now?
Yes, Xavier. The beep sound is not coming out now. If at all it repeats, I'll just let you know. Please carry on.
Okay,
Sorry to interrupt you.
no problem. All right, so as I was saying, right, with automatic query tuning, which by the way runs at the top of query store because it use query store information, right? It's automatically set the execution plan for the query when it detects that a particular workload, right, is using a query plan with regression, right? This is huge, right? Because in an automatic way, right, it is doing what we were doing with query store manually, right? We're gonna see a demo later. In Azure database, with automatic query tuning, we also have the possibility of specify index creation and drop, right, in an automatic way, right? So if the engine detects that a particular query may need an additional index, right, it will create it on the fly for us. And if it also detects that is not needed anymore, it will drop it, right? That index related thing is not in SQL Server 2017. It's only in Azure SQL DB for now. Okay. All right, yeah, as I said before, automatic query tuning automatically monitor all the workload, right, on a particular user database, and it kind of puts certain intelligence, right, to automatically detect and fix performance on the fly. With all this, right, we are able to get a better and smarter execution plan, right? Because as mentioned earlier, right, Microsoft is putting a lot of effort and resources to mitigate the problems that we normally see, right? Execution plan regression, right? So then with adaptive query processing, we will see another angle, right? So how does it work? Or automatic query tuning is constantly learning or checking the query store database, right? All the information that was captured is, adapting or automatically setting the right query plan, right? And then verifying if that one is the right one, right? And that is like a cycle, right? If for some reason it forces an execution plan, right? And then it detects that there is a better one, right? It's gonna fix it later, right? So it will constantly monitoring and fixing the execution plan for us, right? Okay. So here is something that we all know, right? What is a SQL plan choice regression, right? When we see a query, a stored procedure that normally runs, right, in certain particular way using certain execution plan, and for some reason, boom, the stats go to the roof, right? Like, I mean, the most notorious one is duration, right? So with this, we see that this plan gets automatically fixed, right? All right, let's see a quick demo so we can understand and see in action how automatic query tuning works, right? Okay. What I have here is a performance monitor, right? Running on my local laptop, right? And is capturing batch requests per second, right? So right now, my instance is completely idle, so it's doing absolutely nothing. What we're gonna do in this demo is generate workload, right? So we are generating workload, continuous workload, right? So now the batch requests per second are kind of stable, right? So now what I'm going to do as a next step is generate a regression, right? So I enter a regression, and now the plan that I was executing, get some mess up, and it's not doing okay, right? If we go to Management Studio, we can see that with this query, we can identify the data that we have in query store, and we see what it was detected. Okay, the average CPU time changed from 160 milliseconds to 1500 milliseconds, right? So automatically detected that it was a regression, right? And here it's also provided with the script, right, to force that particular query ID to use a better execution plan. So this is query store. So I'm forcing it manually, right? So when I force it, if we go back to my performance monitor, we can see that now the batch requests per seconds are back to normal, right? Note, I will pause this, right? Note that, when the regression started here, right, all this time, and then here, right, the workload was running with multiple regressions, right, until we came here and manually forced the plan, right? Okay, now let's do it again on a different way, right? We are back to let's put this to run and clear here, right? Now it's idle again. But before generating our workload, right, what I'm going to see is do this. Let's see if I can make it bigger. Alter database, set automatic tuning, force last good plan equal on, right? So let's execute this, right? With this, we enable automatic query tuning, right? Let's generate the activity on my instance. Let's put it to start from the beginning, right? So now, we have the problem, right, will be generated now. I will generate the regression and see what happened. The query execution regression is there, but then automatically, right, is going back to normal, right? I haven't I haven't forced the plan with query store. I haven't done anything, right? So automatically, let's pause it here, right? It's set the last known good plan, right? So we only had a regression for few seconds, right? And then it came back to something normal, right? So this is huge because it's kind of doing our job, right? It's constantly monitoring the workload, and if it detects a regression, it's gonna fix it automatically for us, right? I mean, to me, is impressive, and this is one of the reasons why I'm moving all my production servers to SQL Server 2017, right? And by the way, just like a side note, right? Yesterday, SQL Server 2019 public preview was announced at Ignite, right? And well, Microsoft is still investing heavily on these features, right? So pay attention to that because what is coming is really huge, right? So that was the demo, right? So remember, with Query Store, right? SQL Server captures all the execution plan for each single query and the statistical runtimes, right? And then we have the possibility of fixing the query plan performance ourselves, right? With automatic query tuning, we do the same, but in an automatic way, right? We don't have to worry about doing, doing it ourselves. All right. Uh, the other feature called adaptive query processing, right? Well, we all know that the SQL query processing engine is the most sophisticated and complicated part of SQL Server, right? Because it's the one in charge of creating the execution plans on the fly, right? As we said before, based on statistics, based on schema changes, based on the amount of data, etc., etc., etc. Sometimes when a query plan get compiled and we get the regressions, we may see several problems. Like, for example, if we have a particular query that runs, get compiled, and it assign more memory than what is really required, then the following executions will be using a plan with excessive memory grant, right? And if we have the other way around, right? Let's say we compile a procedure that is using, let's say, one parameter, right? And it generates an execution plan based on that input parameter that we got. And then the following executions, right, use a different parameter, and the memory that was assigned on that initial query plan that is stored is too low, right? Then definitely, right, SQL Server will have to spill to disk, right, and use TempDB, right? So the execution is not going to be the most appropriate, right? And the problem that we have up to SQL Server 2017, I mean before 2017, is that when the execution plan get compiled, it wasn't adjusted on the fly, right? So if the query plan was bad because of this problem with memory grants, for example, right, it's gonna keep using it for a long time, right? Okay, now with SQL Server 2017 and with this feature adaptive query processing, right, the engine can automatically adjust certain variables on the execution plan, right, to make that particular query to works better, right? Like for example, memory grant. Then another case that we will see is, with table functions, right? We all know that when SQL work with functions, well, it's sometimes it's doing some funky stuff, right? Like for example, estimating that the function returns only one row or 100 rows in 2014 and 2016, right? Now, what SQL Server does is it get compile the function itself, it gets the real estimate, right? And then it uses to, compilate the, the original or the big execution plan. We're gonna see it in a second, right? So, what we were doing before when we got this problem. I mean, before 2017, well, with 2016, Query Store helped us to identify it, but before what we had to do, it was basically, let's say, forced to recompile the procedure, right? Or maybe had to rewrite the code to make it perform in a better way, right? Well, adaptive query processing, right, change all that, right? And it will always help us to get the best execution plan, but not because it's gonna do it just from scratch, right? It's because it's gonna get feedback from the runtime statistics, right? And it will adjust the plan, right? Let's see some cases, right? The adaptive query processing umbrella, as for today in SQL Server 2017, it has these three options, right? Batch mode, memory grant feedback, what I was talking before, right? When a plan get excessive or low memory grants, right? Batch mode, adaptive join, right? What is this, right? Before, when the query was, I mean, you have a big query with multiple joins, etc., right? Uh, what it, what it used to do is just, decide which type of join is going to use at the beginning, but then, it didn't know the amount of row that one of the joins that we have underneath is going to be returning, right? So now, depending on the amount of row that the previous join is going to return, it's going to decide which join is going to use later, right? It's like, is deferring the decision of which kind of join is going to use, right? And interleaved execution is what I just mentioned about the table function, right? So just an overview, right? Before 2017, multi-statement table functions, right? What it was doing is just, estimating one row, 100 row, and then making the compilation, right? So now, right, we will see it in action in a second, right? It will generate the plan of the table function, right? And then use that plan on the master plan, right? For the grant, again, right? If the initial query plan was compiled with low memory grant, and then the following executions requires more, it will spill to this constantly, right? That is bad for the performance. And the other way around, if we were compiling with too much memory, right, then we're going to be wasting memory, right? So consider this, that with adaptive query processing, it's not only that we are helping a particular process to make better, right? So it's one particular procedure now is running better because it's getting the right amount of memory that it has to use, right? Then all the server workload is going to be much, much better, right? Because we won't be wasting resources, right? So this is help not only a particular thing, but help the whole execution, right? And then regarding to the adaptive join, as I said, right? What it does is that defer the election of using a hash join or a nested loop, right? Depending on the amount of rows that the statement is going to return, right? Let's see it in action. Okay, let's close this, go back to Management Studio, right? How do we enable adaptive query processing? So simple, just changing the compatibility level of the user database to 140, right? When we set compatibility level to 140, we will automatically enable adaptive query processing, right? We don't have to do any other thing. So what are we going to do here? First of all, let's enable the include actual execution plan, just so we can see the difference. So we get while one import is the WW database, and let's set the compatibility level to 130. This is 2016, and then we clean the cache, right? Note here that we have a function, right, with certain parameters. So we're gonna execute this guy and see what we get in the actual execution plan. Right. It's just returning, and then let's see the plan. Okay, what do we get? What do we see here kind of right away, right? The warning sign here, right? And when we see the reason is operator use 10 dB to spill data using execution time. Here, again, right, using 10 dB to spill data. Then here we have the table function, right? Let's try to zoom this. I want to show you something in particular. See the estimated number of rows, 100, right? This is purely estimated. And if we set the compatibility level to something lower, right, the estimated number will be 1, right? So that is the reason why the execution plan is not the best, because it estimates 100 rows, but then in reality, when it does the actual execution plan, it is using much more, right? So now the next part is, let's set the compatibility level to 140, clean the cache, and do the same. Exactly the same query, right? It just ran. We get the execution plan. We don't see any warning signs, so we are not using 10 dB to spill data, right? And for the table function, note this. Estimated number of rows, right? 231,000 rows, right? So is compiling the table function first, getting the real number of rows, and then using it on the bigger execution plan, right? Just to take a better decision, right? Much, much better. And it's coming right with the engine, enabling the compatibility level to the latest. Right? So that is interleaved execution. Let's go to memory grants, right? So what I'm doing here is creating a procedure, right? And then I will execute it with one particular parameter, the number 8, right? So since it was never executed before, it's gonna compile and get with a new execution plan, right? So we should run it. We get the execution plan. See here, right? We have in the warning, right? The query memory grant detected excessive grant, right? It's like it granted a lot of memory, right? And it's not needed. So then let's run it one more time with a different parameter. You saw that before it didn't return a single row, right? But with this parameter, it's gonna return a lot, right? So when it finishes, we go to the plan, and remember, this is configured in compatibility level 140, so it's automatically adapt the memory grants to the right value, right? And it's not using the first plan, right, that had excessive grants, right? So again, we are using the resources in SQL in a smarter way, right? And not only this store procedure, this query will run better, but all the others will do. And finally, we have the adaptive join, right? Let's see what we get here. Let's run this simple join, right? When we get this, notice something. There is a new operator, right? Adaptive join, right? Which basically, put it here, right? With, it's, is estimating, right, that it's gonna use a hash join, right? But what it does actually, it defer the decision of which type of join it's gonna use, right? So this way, right, we can get smarter execution plans, right? All right. Okay, and with that, I just cover all 3 features: query store, adaptive query processing, and automatic query tuning. I hope you enjoyed the presentation. I really encourage you to use all this because it's a game changing, right? And well, to me, I'm taking advantage of all these features every day. So thank you so much. If there are questions, feel free to put it on the chat window. Satya, are you there? Okay, here I see one of the questions saying the performance overhead of automatic query tuning, right, in terms of resource usage. What Microsoft said in terms of overhead is that, just by enabling query store, we had some overhead, right? In my personal experience, that overhead is not too much, and the benefits that we are getting with this feature, worse than just to use some resources. Let me tell you something. What I did before enabling all this feature, I took a baseline, right? One of my most important environment, I took a baseline, right, of in terms of resources, I/O, memory, and CPU, right? And then I enable query store and automatic query tuning just to compare those resources, right? And to me, I haven't seen any difference, right? It didn't affect at all. And even, I mean, I was willing to see some, let's say, more CPU usage or more IO or more memory. I didn't see it, right? But even though I think that these features are worth to use more resources on them. Well, I hope that the question is answered.
Hi, Javier. I'll just request audience to post their questions using Q&A panel. Meanwhile, Rohit have few slides. So while Rohit is presenting his slides, please post your questions using Q&A panel. Thank you.
Okay. Are we able to identify parameter sniffing problem using query store? Well, we can see something, right? But the way of detecting and mitigating parameter sniffing is an additional feature that we have on SQL Server 2017 called scope database setting, right? So it's a setting that we enable per database, right? And it's allow us to force a setting to mitigate parameter sniffing, right? So it's also quite simple to use. Query store, if we change the SP, it still, okay. If we modify a store procedure, well, definitely it's gonna change the execution plan, and the store procedure will get a different ID, right? It's gonna be like a completely different procedure if we change it, right? So we're gonna keep, let's say, two branches, one for the original and then for the new one. The original, the query plan, we set the amount of space that we, assign on the disk to store query store information, right? Let's say 100 megs, 1 gig, whatever, right? And then that amount of space get recycled, right? So the oldest data, right, is going to be overwritten by the new one, right? So we also have to adapt the amount of space that we grant to query store depending on the workload that we want to keep, right? If we want to keep several days, well, maybe we have to adjust this to something bigger, right? The default amount of memory, the default amount of space is 100 meg. All right. Well, I saw these two questions, the parameter sniffing and keep track of changes in the store procedure change. So if there are no more questions, well, feel free to reach me by Twitter, by LinkedIn. Here is also my blog, right? Well, thank you again.
All right, Javier, thanks a lot for your session. It was a wonderful session. I'll just take 2 minutes, and then maybe if there are any more questions, they will meanwhile put it on in the Q&A panel.
All right.
So thanks a lot, everyone, for joining us today. Hope it was worth your time. I'll just take a few minutes of your time. If you have any more questions after the session, you can always post it on the Facebook and the LinkedIn groups. And like I said, on the mobile as well. You can always follow the links. And a word from our sponsors, we have SQLMaestros. Like I said earlier, we have hands-on labs, on-site training. You can check them out at SQLMaestros.com. We will be starting with the masterclasses soon. Masterclasses will be 8-hour classes, 4 hours each day. And we have a lot of classes on Microsoft Data Platform, AI, Data Science, SQL Server, Power BI, R, Python, etc. And these are some of the world-renowned experts that will be joining us for these classes. You can, again, contact the numbers that are given. We also have HOLs. If you want anything self-paced learning, you can always access these hands-on labs. As you're already members, you can access some of them. And please do go to SQLMaestros for more information. Once again, thank you for your time. If you have any more questions, you can put it down in Q&A, and Javier will definitely answer them. Thanks a lot for your time, guys. Thank you.
Thanks, everyone.